Arr, have you ever wanted to catch a pirate broadcaster and make him walk the plank? Well, we've got a guest who's done exactly that, kind of. Nick Straka is our guest. He's a contract engineer and consultant in the New Jersey area, and he's joining us on This Week in Radio Tech to talk about pirate radio, as well as FM translators and low-power FMs, how to build them right. This Week in Radio Tech is brought to you by the new Ruby console from Lavo with AutoMix Smart Mixing. See Lavo in your future at lavo.com/TWiRT. And by the Telos VX multi-line, multi-studio on-air phone system. Get return on investment and HD voice for your stations with Telos VX. Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack, your host. I'm delighted to be here. This is the show where we talk about everything from, look at this microphone, from the microphone to the light bulb at the top of the tower, and all the stuff in between, which nowadays is a lot of digital stuff, but we still do analog. You know, I guess with the exception of 2 microphones on the planet, they all have analog outputs. Maybe a few have an AES output, but those usually have a power supply box. Anyway, that's the idea. We talk about radio and audio and RF and the things that it takes to deliver interesting, creative, and maybe sometimes not so interesting program to literally millions of people every day and every week. That's what we talk about here on This Week in Radio Tech. We talk about it from the aspect of engineers, broadcast engineers. So today is no exception. I'm Kirk Harnack. As I mentioned, I work for the folks at the Telos Alliance. That's my full-time job. So if I have a bias toward their equipment, well, it's because I know all about it. And I eat my own dog food. I do put a lot of audio over IP and Telos and Omnia and Axia gear at my own radio stations. I'm part owner of about 12 or 13 radio stations now. The group just keeps getting bigger. But and it only stops when the credit card is full. That's what it limits the growth. So today we have a guest with us who is, I've been wanting to interview Nick Straka here for a while, and he's been able to find time. I think he's snowed in. That's probably why he's here. Welcome in, Nick Straka from New Jersey. Hey, Nick, glad you're here.
Hey, Kirk. I'm glad to be here. We did get about 13 inches of snow, and combined with the storm last week, that was very interesting last week, too. I've had a site that's been on generators, still is, since last Friday. We had to run fuel up there in a Snowcat on Monday, so that was quite an adventure.
What? Now wait a minute, a Snowcat that's used in mountainous areas like the Rockies. What's it doing in New Jersey?
My site it's actually in New York State, in lower New York State in the Catskills, okay. And it's about 2,400 feet in elevation, and it's a long 1.5 mile road. It's a power line cut that gets up there, and generator was running low on fuel, so they strapped a 100-gallon tank on the back of this Snowcat, and we ran it up.
Wow, I had no idea. Now, I've heard of the Catskills. I've never been there. 2,400 feet is kind of a, for Tennessee, that's a big hill. But
yeah, for our friends out west, that's a molehill. It's nothing, but
but it's a power line cut, which means it's not a real road, is it?
No, they put some gravel down to smooth out the muddy spots. So in the summer, it's passable. I can get up there in my car, but the Subaru makes it up there. But in this weather, 2 feet of snow up there, absolutely not.
Wow. So I had no idea you could rent a Snowcat. Is it yours, or do you rent it, or how do you get hold of a Snowcat?
The tower company actually owns the Snowcat. They run two-way radios, and they own a bunch of towers up there. They're wonderful to deal with, and it's quite refreshing from some other tower owners where their attitude would be, "We own thousands of towers. Too bad."
You know, I had no idea we were going to talk about this. There are plenty of people listening to and watching this podcast that may not have any idea what a Snowcat is. Frankly, I wouldn't know what it was unless I had done some work in New Mexico, 30 years ago. And we rode a Snowcat up to the top of a mountain. Tell me about Snowcats. Why do you need these? What are they?
It's a snow tank, is what it is. It's on 2 giant treads instead of tires, and because the treads have so much surface area, you're on top of the snow. So it's deceiving. Okay. You're riding up in the Snowcat going, well, I could have made it up this in my car. And then you get out and the drift is up to your waist. You don't realize what's going on when you're riding in this thing doing 20 miles an hour blasting up the road. It's a lot of fun. It's sure beats going up in snowshoes, which would have been the alternative. And I don't think I could have hauled the fuel up with snowshoes.
No. Wow. So how much is the difference in elevation from where you start and where you end up at the transmitter site?
It's not a lot. It's maybe 500 feet because you're already up on the mountain on a paved road where people live, but then you have to get off of that road and go through the power line cut and then make a right and go up the hill and wind up at the transmitter site. And what happened is I had a client up there. I have 2 stations on that tower, and they have a UPS, which holds things up in between when the power goes out and the generator comes on. Well, this UPS didn't like the new generator. So the UPS decided, I'm not going to turn on at all. I don't like the frequency of the power coming out of here. Tough. I'm off. They didn't spend for an automatic bypass switch, which they're going to buy this week. So the transmitter stayed on. All the rack equipment went off.
Ah, because the transmitter was not powered by the UPS. It was just a transfer switch.
Right. A 12 kilowatt transmitter. It'd be one heck of a UPS to plug into that thing. So we wound up, just broadcasting Simon and Garfunkel, The Sounds of Silence, for a little while.
So I've dealt years ago with UPSs that were unhappy with generator power, and these were cheaper UPSs, and they had a little dip switch they were shipped with a narrow range of acceptability of the incoming power, and I had to move it to the wide range, like it accept, okay, if it's kind of close, I'll charge on that, and I'll pass that along down line to what's plugged into me. What kind of UPS are we talking about here, and how did you change or fix that?
This was a trip light, and the UPS that was in the rack next to it actually caught on fire, and that wound up in the woods. So I don't know what was happening up there with the frequency of power coming out of the generator. So we just bypassed the UPS for now, plugged everything in a power strip, and it's happy. And my feeling is if it blinks off for 2 seconds when it goes from the generator back to shore power, that's better than being off for a few hours while we wind up having to get up the mountain in a snowstorm. So that worked out better. The online double conversion UPSs, if you're going to put one at a remote site like this, that's the way to go, because your little APC that you buy at Staples, and you go out there and you buy a UPS, you plug it in, you feel all proud of yourself, and you have this thing that it's on the power grid all the time. So when the power fails, a little relay inside flips, and you go to battery power and the inverter. So if it fails, it just fails. It's done. It goes off. It doesn't pass any power. The difference with the double conversion is it takes the incoming power, converts it to DC to charge the batteries, so the batteries are always floating, and then there's an inverter on the other side of the batteries, which then takes that power, converts it back to AC, and gives you actually perfect 120 volts, 60 hertz AC coming out the other side. So it smooths out any bumps in the line, especially at a site like this up in Liberty, New York, at the end of the line. So it's very bumpy power to begin with. And then what happens is if it fails, if the batteries go bad in the UPS, instead of failing and just shutting off, it fails back to shore power. So at least if you have shore power of some sort, like a generator or something, you have something in line. And what I like to do too is if you have that, that's great, but I'm also going to put in an automatic transfer switch, which actually APC sells those. They have 8 outlets in them. And if the UPS goes away, that's your primary input is A. If that goes away for any reason, it flips over to B, which is just your direct connection to an outlet or a circuit.
So, Nick, I always thought that the biggest advantage of the double conversion UPSs was that if you've got a lot of CPU equipment on the output of the UPS, which, I mean, who doesn't nowadays? I mean, the audio processor, you said you had an Omnia 1 there, that's running a CPU and DSP chips. Anything that would be sensitive to a quick power bump.
The FlexStar Exciter is a huge computer with a transmitter attached to it. It's all computers, and there's actually a computer at the site too.
So that's the kind of gear you don't want on a relay. No matter how quick it is, it's still going to drop the power for a few milliseconds as it moves.
Right, and
that's why you want a double conversion.
Yeah, and what it's doing is it's not smoothing out the power. It can correct for over voltage, under voltage to a certain, I think it's usually about 5 to 10% over and 15% under. It can try and bring that up. But the online UPS, you're always floating on the batteries. You're always on the inverter. So whatever's coming out of that, no matter what's coming in, if the frequency's going all over the place because there's an industrial plant down the road, if there's bumps in voltage or dips or sags in voltage, it doesn't matter. What's coming out the other side is clean power.
Something I'd love to explore on this show, and this probably isn't the episode to do it, unless you just happen to have a lot of knowledge about it, is I've been to some third world countries. I've been to Haiti, for example, to an orphanage where so many houses, so many people, so many businesses have a huge bank of lead acid batteries outside. And, being warm weather there, they just, put some plywood over them to kind of sort of protect them. And then they have an inverter, and it's kind of big. Typically, it may hang on the wall, or it may sit on top of the batteries or nearby the batteries. And but with that huge bank of batteries, they literally have power for hours and hours and hours to run refrigerator, freezer, the things that a fan, some lights in the building. And I've been talking to a friend of mine who keeps telling me, "Hey, Kirk, at your radio stations, you don't need to spend $3,000 on an APC or Trip Light or other brand of rack mount UPS. If you really want to get a lot of power for a long period of time and not spend an arm and a leg, go buy a bunch of 12-volt marine batteries and get an inverter. I'll send you a link and use that." Now, have you heard of stations doing, lashing up their own that way, the way they do in Haiti or the Dominican Republic or other places where the power is not so reliable?
That's precisely what I'm doing on top of this mountain. After we've had one UPS catch on fire and the other one not be happy, the owner said, "Well, is there a better solution?" And right across the way, the tower owner owns, they service two-way radio. So the ambulance is on there, the police, the fire, and they all have these batteries with the inverters off of them. And I said, well, if that's good enough for the police and fire, that's definitely good enough for this silly radio station. So it'll be fine. So we're actually taking, it doesn't need to run long because it just needs to hold up things until the generator gets on. Because if the generator doesn't start, the 12 kilowatt transmitter is not running anyway. So it doesn't matter at that point. If you have batteries that hold the thing up for 5 days, if the transmitter's not on, no one's hearing it anyway. It just needs to hold it up for a couple of minutes. So we're taking two marine gel cell deep cycle batteries, an inverter, and a trickle charger that automatically floats the batteries and keeps them at optimal voltage. And we'll see how that goes. So I'm rolling my own for this.
Okay.
One.
Yeah, years ago I spoke with an engineer up in Oregon. I maybe need to get him on the show and he was doing the same thing. Or maybe I'll find somebody who can talk to us about how to do that, because I am interested in doing that for my own stations. We typically at our stations we often have power outages of 20 minutes to 2 or 3 hours, and we at this point we just can't afford a generator and a transfer switch there. So I'd love to just keep the PCs and the automation systems and the Ubiquity IP radio link. I'd love to just keep all that running for several hours. I think we may be talking about a total of 3 or 4 kilowatts. And anyway,
it's just a matter of, the nice thing about it is it's modular in the sense that I need more storage, so I just add more batteries to it. And at this point, if you can run a Tesla for 300 miles, you can definitely run your equipment off some batteries. It's just how many batteries are you going to throw at it? That's really what it comes down to. How much capacity do you need?
We'll have to find which of our staff members, has a hybrid car and say, "Hey, bring that Toyota over here. We're going to plug into."
I've got some jump cables.
I'm going to
clip them on here.
We need your Prius.
You don't mind, do you?
you don't mind, do you? No, you can't leave for dinner. We need the car here. We'll
back
call
that
you
$120,000 Tesla up here, and we're going to put some jumper cables on it to keep the radio station on the air. You don't mind at all, right? It'll be fine.
We ought to get to the topics we were going to get to, and by the way, if you're just tuning in, Nick Straka is our guest today. Nick, tell us. We didn't get around to having you tell us a little bit about yourself. You're in business for yourself as a contract engineer and consultant. Yeah.
Since 2009, I started in radio in 1995, and always. I did on air, I did programming, I did production, I did everything else, but I always did engineering at the same time too. And that was the thing that it was my first love was tinkering around in the basement and building a studio and building little transmitters and trying them out and seeing what I could do and how everything works. The first thing I would do is I get something and as a kid, I'd pull it apart and see what was inside, see what made it tick. Even if I didn't know what everything was, I'd ask questions and find out. So 2009, I decided after I got laid off from a job, and I said, that's it. I'm not going to put my fate in the hands of somebody else. I'm going to make a crack at this. I'll see what happens. And I haven't looked back. So it's been really rewarding and good. And get bored easily. So I like the different station, different thing, different problem every day type of aspect of contract engineering. It's a lot of fun.
You know, there are a number of contract engineers in our business who are in business for themselves. I was back in the late 80s and through the mid 90s. And then when consolidation came along, it just seemed like, there's going to be a plethora of engineers here for a little while. Not anymore, but there was for a while. And it's maybe a good time to go work for somebody else. But hats off to you. And I hope that you can we can find a way for you to share your experience and knowledge and enthusiasm with other up-and-coming engineers, because I do think that contracting with stations, broadcasters, other content creators is a really viable way to put your knowledge to best use, and it's so different from some other kind of job. I'll share with you just a second. I had one employee who worked for me when I was a contract engineer. He had worked for me for about 3 or 4 months, and he said, "Hey, Kirk, when are we going to get some training on the pieces of equipment that we work on?" And I had to say, "Jerry, that's a great question. The problem is, this isn't like working for a copier company where you have 17 models of copiers and they share a whole lot of the same parts and they're all the same brand, and you get training on these, and then you know all about your job. We literally have probably 400 different types of equipment that we work on, different brands, different models, different types of equipment, and I can't possibly train you on all these. You have to learn the basics of what they do. You have to learn the general principles involved." And
when we get there, you'll see the specific one. That's kind of it. It's okay. Go fix the transmitter. Well, is it a tube transmitter, a high power transmitter, a low power transmitter? Is it 3-phase, single phase? What is it? It's more right. It's not just the copier. Like, well, it's the big copier. That's the little model, and there's the two in between. Have fun. It's a whole different ballgame, and you walk into different studios as a contractor, and there's different general managers, different corporate cultures. Some are single owners, and I have some of my small stations which are single owners, which have no problem spending money, and the corporate ones are like, no, we don't want to spend money on that. So it's a balancing act, is what it is. Trying to keep your customer happy, but also keep your sanity. And it's my name on my work out there, so I want to make sure that everything I do is up to a certain standard. And sometimes it's very easy, and sometimes it's very challenging when they say, well, here's this handful of cash, make it work.
You know what we can do, though, even though it's hard to get specific training, although, I mean, you can go to Gates Air and get trained on a particular transmitter. You can go to their either week-long or several-day-long seminars where they train you on their HD products and so forth. And other manufacturers can do that as well. A lot of folks go to the Nautel Users Group in Las Vegas and learn a lot of specific things. But what we found was that, of course, it's helpful to have some of the same equipment at every station, or enough of it to where you learn the idiosyncrasies, for example, of, let's say, an audio vault automation or a wide orbit automation or a Rivendell. And then you can say, oh, hey, I saw this. I saw this at another station. Or a station may ask you, can we do this kind of broadcast remotely? Yeah, and we did that with another station, so I'll just take that solution and make it work for you, or I'll adjust it as needed. Point being, once you get to be good at knowing what typically goes wrong, and I come from back in the day of ITC cart machines, right? So I made tons of money rebuilding triple-decker ITC cart machines and learned how to do it really fast.
The line? That's what I started working on was ITC cart machines and BE 3000 series cart machines. I can align heads on a cart machine, a completely useless skill in 2018,
Nowadays,
but I can do it.
Exactly.
I can also fix your wagon and tend to your horse, too.
I don't know if I can do that very well. So we were going to delve into some of your expertise on FM translators, and this is a good topic nowadays because FM translators are pretty popular nowadays. That's the kind of thing that people have been applying for. The FCC has been granting licenses for them, and there's different styles, I guess, and different possible uses of translators. I'm not sure that I understand them all. I don't know that we were going to talk about that, but you have a lot of practical experiences in building new translators as well as LPFMs, making them work, and helping an owner decide, I'm going to spend money on this aspect of it, or here's an area where I can save money because it won't matter to the end product. Why don't you talk to us a bit about kind of give us a lesson, walk through your experience with FM translators and some tips that you'd like to leave us with in that regard.
Well, one of my first jobs was at the infamous or famous, whichever way you want to look at it, Jukebox Radio, which was just outside of New York, and that was a chain of translators. It was a primary station up in Liberty, New York, which is actually the same one I was talking about with the Snowcat. I wound up getting that station back as a contractor. So it went from there. It got bounced from the primary station to a 3.5 watt relay that was 50 miles away in Rockland County, New York. I could draw this on a map for anybody. Just email me and I'll make a little map for you of how this worked. And then the 3.75 watt translator was picked up again about 27 air miles away in Fort Lee, New Jersey, and translated out on 103.1. There was a lot of FCC battles. Just Google Jukebox Radio. You'll see the whole thing. But that introduced me to this concept of translators. I really never thought about them before that point. And it was interesting to see how low power can work, how 3.75 watts, you don't think about receiving that 27 miles away. Well, you have a high enough gain, directional enough receive antenna, and you can pull it off. And it was quite remarkable that it worked. On days where there was some tropo or interference, it was fun. There'd be a rock station on from Virginia, and we get the calls from listeners. Did you switch format? And it's like, no, we didn't switch format. Just give it a few hours. It'll go away. It's fine. Because we were playing oldies and big band. So it was, Black Sabbath would come up. It'd be quite different.
Oh, my goodness. How do you explain that to a listener? Because, sorry, we have to feed our station over the air. It's the only way that's legal. And over the air isn't working right now.
It's very tough to explain. Like, the radio in your house, take that radio and plug it into another radio. And that's kind of how we're doing this. So that started me on translators and just thinking about low power and thinking about how that worked was there's second adjacents on either side, but you put it up high enough and you drop the power, and those second adjacent interfering contours don't actually hit the ground. So that was like the first kind of loophole, which is being done a lot with the AM fill-in translators now. So it got me going on this, and worked for some full power stations along the way in between there. And as a contractor, I've inherited that chain of translators back, which are now fill-ins, so they're not being fed off the air anymore. There's an HD filling those, and just building them and really thinking about the practices with that. And we treated the translator as a real station, and I think that's the key to the whole thing. Is you don't think about it like, oh yeah, it's just this little translator thing. I don't need to worry about it or put any significant amount of money into it or invest in any backup systems. If you rely on it to get your audience, which a lot of AM stations do now, or someone who's, say, leasing an HD and using that translator to reach their primary audience, you have to treat it like a real radio station, and you have to treat it the same as you would treat a full power radio station.
Okay. These translators that you're talking about that were part of Jukebox Radio, I take it that even though they may have been relatively low in power, they still covered a pretty good population, because you're very concentrated in population in your area, right?
They did. The Rockland County station on 94.3 served as mainly a relay. It covered a few miles around on the ground, but it was up at 1,600 feet above sea level on a mountaintop, and the receive site was 500 and some feet up in Fort Lee. So that worked to feed it. And then the station in Fort Lee was 35 watts, and there was about 3.8 million people in the 60 dBU of this translator.
And this is interesting. There's another group, whose name I won't mention, but they have a lot of translators, and boy, they purchase audio processing gear from my employer, Telos Alliance. And they base their purchase not on the wattage of the translator. They base which model they buy, and that they may spend $15,000 on a processor for a translator if it's going to be covering a lot of people. And they have a number of them that do. So that opened my eyes. That's been 12, 15 years ago when I learned that about this group. And I thought, that's pretty smart. It's not how many watts it is. It's how many people are you covering?
Right. That thing is 35 watts, and it covers millions of people. And there's other translators that are 250 watts and don't cover. There's 100,000 watt stations that don't come anywhere close to covering that many people.
Yeah.
So it's not how many watts you have. It's where they are. It's just like real estate. Location is everything. And so those two that translator there in Fort Lee now, and its companion translator in Manhattan, I'm running Omnia 11s with GeForce on them.
Wow. Yeah. Well, you're covering a lot of people there, and you're competing with other stations that have that processor or maybe some competitors. So
right. That's what I tell a lot of people with LPFMs too. Is I have an LPFM that is about 25 miles from New York City, and he was putting the budget together, and I said, you really need to budget this amount for an audio processor. He says, well, it's built into the transmitter. What do I need that for? I said, you're sharing the dial with everybody from New York City. You have flamethrowers on either side of you. You need to be in the pack with them. And we wound up going with an Omnia 7 on that station, and it's louder than its neighbor from New York City, which is kind of fun to listen to this little 4-watt LPFM blasting away like that.
That Omnia 7 is pretty amazing. We're not doing an ad for Omnia today, but we could, because it's an amazing processor. Hey, so let's talk a bit more then about building and maintaining translators and LPFMs. I'm wondering, what are some of the things that you've learned where it's important to spend some money if you want to be successful at this?
The biggest place that you can do proper engineering and spend the money is the antenna, because if people can't, you have a handful of watts, and if people can't hear you, everything else you're doing before that is just academic. Great, you have an Omnia 11 with GeForce, well, you have a garbage antenna, and your signal doesn't get out the way it should. I had a situation where we put up an antenna, and the owner of the LPFM said, well, I just want to spend this much. So I said, fine, we'll make it work. We put the antenna on the tower, and we light it up, and everyone's driving around going, my goodness, this is horrible. We can't hear it. I'm staring at the tower, and I can't hear it. So I called up. It was an ERI antenna, too, so it wasn't a cheap antenna. So I called up ERI, and I said, listen, can we run? We don't have money to put it on the range and put it on the turntable and do that whole thing, but can you run a computer model? So runs the computer model on it, and the computer models come back. And he actually called me up and said, Nick, can you call me? We need to talk. I said, okay, I'll call you back. He said, this is the worst I've ever seen. Well, if it isn't the worst, it's one of the 2 or 3 worst I've ever seen. So it was something with the frequency of the station on 107.9, the cross-section of the tower at that spot on the tower. He said, I've tried routing things out. I've tried everything. I can't make this work. The tower owner was nice enough to let the station go up probably about 20 feet on the tower to where the cross-section changed because it tapered. We did a computer model, and they custom fabricated a mount for the antenna to get it just the right distance from the tower and just the right azimuth, and it smoothed the whole thing out. And it's 4 watts because it's up way high on a mountaintop, and it gets out pretty far. You can hear it 10 miles away from the transmitter, which is pretty good for 4 watts.
You bring up a really good point, and that is about the interaction between an FM antenna and the structure that holds it. In an ideal world, we would have towers that were electrically invisible.
They're made out of fiberglass.
Yeah, a fiberglass tower to hold our antenna, because it's actually kind of a bad thing that we do. We have this antenna, and it's putting out electromagnetic radiation, and what do we have right next to that antenna? We have a big hunk of metal. Big hunk of metal that is going to absorb or re-radiate. It's going to vibrate sympathetically. It's going to, and then when it re-radiates, it's going to re-radiate either constructively or destructively, depending on the azimuth, the direction around. And we may, as you experienced, get a horrible picture of the coverage in the desirable areas. And so, yeah, we can, through modeling, through range testing, we can minimize that interaction between the antenna and the structure that holds it. Now, that's why, well, here in Nashville, just a few miles south of me, there is what a lot of people in Nashville call, the FM tower. I think it has 4 FMs on it, but the top FM, there are either 2 or maybe there's 3 stations that are all triplexed together into one master antenna there. And it's not a panel antenna. It's an ERI rototiller style, but it's on a pole. So the top 90 feet or so of the tower is a big pole, which means it's not a big cross section. Sure, it's a vertical thing, but it's not very wide horizontally. And so they get minimal interaction by mounting on that pole. And ERI offers, and probably other manufacturers do too.
Lambda section.
Yeah, a lambda section, sure.
which is tuned to that specific antenna specific frequency to either make it as circular as possible, or within reason you can also, as a non-directional station, as long as you don't go too crazy like the guys in Texas did, where they were putting almost 200 kilowatts in one direction, you can kind of massage the pattern to get it over the population centers and not cover as much rocks, birds, and trees if you really want to.
I've heard of that being done. Yeah. Well, we're 70 miles from the city of financial interest, so we're gonna try to
blast away
optimize.
that direction.
Yeah, yeah. All right. So and in antenna, you bought a quality antenna, and but placement and the structure to which it was mounted was a problem. Generally speaking, if you have to locate your antenna on a tower with a very wide face, like you're renting space on a TV tower or a great big tall tower, that's probably going to be problematic right off the bat.
Yeah.
Go ahead.
It's not going to be an Omni when you put it up there, no matter. And usually, if you look at the antenna pattern, even in free space, they're not quite Omni either. They pull in a little bit at the back or the side. If you look at, say, the Nikon BKG 77 antenna, it's actually quite a directional antenna. There's not a lot of. It's about 40% of your radiation is gone off the back of that antenna. So you hang that on a 7-foot face TV tower, you're definitely going to want to put it facing generally the direction that you want your radiation to go in.
Yeah, and that's a rule of thumb, although we all know that can be easily thwarted by other factors there. So, okay, so a good antenna. What do you typically use for transmission line?
Transmission line, it depends upon how long the run is. Generally, for an LPFM or a translator, 1/2 inch is good. I have a couple situations where I have pressurized antennas because that's what Shively needed to make the pattern, was a certain model of antenna, and it was pressurized. So I ran 7/8 air up to that. If it's a long run, if it's 400 feet up a tower, you could wind up running 7/8. Generally, at translator power, it's cheaper to just buy a bigger transmitter than it is to put 1 5/8 up there to minimize the loss. It's cheaper just to make the watts up on the ground instead of trying to put a big, heavy transmission line on the tower and possibly get charged more in a tower lease for the big transmission line.
Gotcha. Okay. And what we're talking about here, for those listening, the larger, generally speaking, the larger the transmission line, the less loss that it exhibits at a frequency of 100 megahertz, at the FM band. So if you got to run a long ways, you're gonna lose some power in the line. It'll dissipate its heat because the line is not a perfect, conduit for the power. But there comes a trade-off. Sure, you can, like, I've got a transmitter site, for example, that we had 1 5/8 line come off the tower. Various reasons why, but it came off the tower. It was no good anymore. We could not easily afford to replace it exactly as it was, so we bought some smaller line. I can't remember if it was maybe it's 7/8 line. But the bottom line is we put the 7/8 line in, then and only then did we go, you know what? We can't make our ERP with this line. We can't shove enough power in the bottom of it with the transmitter that we have to get into that antenna. We may have also changed it. We used to have a 6-bay antenna up there. Now we have a 4-bay. Bottom line is we made a bad decision. We used too small coax, and we couldn't get a big enough transmitter for what we could afford to shove power up into it to get our full power out. So eventually we're going to replace. I mean, we're actually at the 10%. We're at the 90% mark. We're putting out 90% of our authorized power, so we're legal, but just barely. And there's no comfort, no margin there. So anyway, selection of coax.
Right. You're running your transmitter flat out at that point, and
yes,
you really don't. You want to have a little bit of wiggle room, especially with the VSWR. If you get an icing situation, I don't know how often that happens in Tennessee. It happens a lot here. I'm sure up in the mountains on a tall tower, you get some icing situations there and some foldback, and you want to have some wiggle room on the transmitter. The size of the line is two things. It's the loss. The larger line you have, the less loss there is. I have one site that I inherited from Flow TV and Media Flow, and they spared no expense. They ran 3-inch line to the top of the tower, so we put our FM antenna up there. I plugged into the 3-inch line, and the joke is the line has gain because it's so big.
The line has gain. Wouldn't that be awesome?
Plug it in the line. There's 1,600 watts going in. There's like 2,000 coming out the top.
Can you imagine how much money you'd make if you could do that, and how much Nautel and other transport companies would hate you? Oh yeah, we got gain line. What's that?
The new gain line. I could probably sell that. Remember the little things they used to sell in Popular Science and Mechanics that was plug this into the wall. It's your TV antenna. It uses the whole house, completely ignoring wavelengths or anything like that.
Your whole house
could probably sell it to some people.
Or years ago, my colleagues and me at Telos, we developed a bogus product called Wi-Fi spray. It improves the speed and bandwidth of your Wi-Fi. You spray it in the room, and then just on a lark, we Googled it. Somebody else was already scamming people with Wi-Fi spray.
We can sell that. We can magic smoke too. We can sell that one in a bottle.
There you go. Hey, so coming up, we're gonna take a break here, but as we continue, you've got a little AM directional experience. I'd like to hear about that briefly, and then we're gonna talk about something really interesting, especially for engineers who are in populated areas where you have pirate radio stations, because Nick has a lot of experience with pirate radio, and not as an operator. Well, except for that high school thing. We're going to talk about that coming up. Hey, our show This Week in Radio Tech is brought to you in part by my friends at the Telos Alliance, and specifically the Telos VX VoIP phone system. And we're talking about
you already have that. So
we need to turn the side there. There you go. Thank you. So Nick and I are going to, as these images roll by here, Nick is going to be installing a Telos VX pretty soon. This is the system where you got VoIP lines coming in on one side, and the VX system groups these lines together into shows, gives you Omnia audio processing on every caller, and puts it all over AOIP, audio over IP, for distribution into your studios. So one box like that one that's on the screen right now, a 2-rack unit box, can easily, basically has 24 hybrids, 24 fader channels on consoles, and they don't all have to be in the same room, of course. You can have, if you have 24 studios with one telephone fader channel to put one caller on the air, then there you go. You can actually button mash several callers onto one hybrid, but it's just amazing how the system works. By the way, that box is fanless. It is perfectly silent. You could put it in the studio. Not that you would. You probably have it in your rack room. But you bring your voice over IP into one jack on the back of it. We're going to show a picture of the back here. So there you go. There's 2 network jacks. One says WAN and one says LiveWire. By the way, this thing has 2 power supplies, as you can see there. So the WAN jack is where you plug in your voice over IP. The LiveWire jack is what goes to your LiveWire network. Now, if you don't have a LiveWire network, no problem. You can just put some of the Telos Alliance X nodes wherever they need to go. You can put them in the rack room, or you can put them out in each studio as needed to give you audio I/O. You can also get the model that has the contact closures, the GPIO. So you could put one of our, for example, our mixed signal X nodes out in the studios and take care of your GPIO for tally lights, ringing lights, and muting and all that kind of stuff, as well as get caller audio in and out and music on hold. These are the VSET 6 and the VSET 12 to control your system. You can also control the system with a variety of different software packages. There actually is a software package that comes free with the system. It's called X-Screen Lite, and then you can get other call screening softwares to do that. Not only do they put calls on hold, let you type stuff in, these software packages let your call screener talk to the caller via the PC. So you can just plug in a USB headset and have your call screener talk that way. You don't have to have one of these controllers at the call screener position. Yeah, we'd like to sell you one, but you don't have to. And then some more options for controlling the stuff is available built into the consoles. Of course, there's also a model for the new Fusion console. Built into, you can get an Axia IQ console telephone expansion. Lots of ways to get this done. There's another drop-in module that is available to work in any other brand of console. The electronics, it can get married up with metal provided by another console manufacturer. Now, Nick, I understand that you are about to put a VX system into a station. Why did the station choose to go with a VX system?
It's going to be an all-new build, and what we decided was, well, we're not going to bring POTS lines into the building in 2018. It just doesn't make any sense. I might bring in one that runs a Silent Sense remote control or something like that that's just separate from the system. But for on-air calls, it's so much easier to have multiple studios running off of this one box. It's hybrids in the sense of DSP is separating the caller and the send audio, but it's not an actual hybrid like an old POTS hybrid. So you can your density of what you can fit in one little 2 or 3 rack unit box is incredible. So if they need to add another studio, they want to add an edit bay, a production bay with phones, great, fine. I'll just run it over here now. And here's another phone line. It's not, I don't have to punch it in. I don't have to put a separate hybrid in. I don't have to go through all of that just to get phones on the air. It's easy. I think that's what the thing is. People are scared by VoIP, but it's not that scary when you just start treating it like data and then treating your VX just like you would treat your hybrid. Feed it a mix minus, take the audio out, and put it on a fader.
You know, I remember myself learning about VoIP, and I'm still learning. There's stuff to learn, and
oh, me too.
So hard to wrap my head around, because as engineers, we've been so accustomed to a pair of wires is a phone line, and that's what it is. And so if you want 10 phone lines, you have 10 pairs of wires. And I realized, okay, maybe having T1 circuits, helps you understand the idea of multiplexing several lines onto one pair, actually 2 pairs of wires with T1. But over Ethernet, I mean, over the same Ethernet cable, you can have video and file transfers and Netflix and email going on and 100 phone calls all at the same time on just a piece of Cat 5 wire. And it's just and to think about, okay, now that's my phones coming in. Yeah, but where are my lines? Well, they're all in that Cat 5, and now it becomes kind of virtualized. But you learn to deal with that. That's the point I want to make about the TELUS VX. If you are replacing, I'll tell you what, I'll back up. For decades, we as engineers, we've always thought about replacing phone systems one studio at a time. Hey, Studio A needs a new phone system. We're going to budget that for next year. Hey, Studio B that can wait till 2 years from now. Well, we no longer do that. Now with the TELUS VX, we replace all the studio's phone systems, and we get a heck of a value that way. Now, if your studios already are live wire, Axia, audio over IP, wow, this becomes very, very inexpensive on a per studio basis. If you don't have that, not a problem. You're just going to spend a little bit more for one of these interface boxes, an X node, either in each studio, or if your needs are limited, you can have one X node to feed 2 studios. In fact, you can usually do that. Have a couple caller channels and a mix minus channel coming back out of your board, and a music on hold channel for that studio. So there's ways to configure this depending on, do you already have live wire? Do you not have live wire? Do you already have some other brand of audio router in your studio, in your station? The folks at any of our dealers can help you out, and any of our sales reps at the TELUS Alliance can help figure out the most cost-effective way to do this. The other thing you can do with a TELUS VX is you can put an asterisk phone system in front of it. And honestly, this can run in a cheap computer, or you can buy something that's very robust. You can spend anywhere from roll your own for a few $100s, or spend buy something very robust for $5,000–6,000. And what this system will do for you, what an asterisk-based phone system in front of a VX will do for you, is it allows all kinds of cool stuff, like conferencing, like having remote talent call in using G.722 codec from an app on a cell phone, and have HD voice into your phone system and put that on the air. The TELUS VX speaks HD voice, speaks G722 natively. So it's a great option for putting people on the air and having them sound better. You can also play, some big station groups require, hey, we have to play a legal disclaimer to the callers before we put them on the air, before we'd let them win a contest. And you can do all that with an asterisk phone system. Talk to us at the TELUS Alliance about a VX, about going to VoIP. And honestly, I got a video about this. You can pay for this stuff in anywhere from 18 months to 3 years with return on investment because of the lower cost of VoIP lines. Thanks a lot to the TELUS Alliance for sponsoring This Week in Radio Tech. All right, Nick Straka is our guest, and let's see. I'm gonna guess that if Chris Tobin becomes available, he will let me know in the chat. So I don't see him in the chat yet, so I guess he's not available. Chris Tobin is normally here. I'm Kirk Harnack, and again, Nick Straka from New Jersey is with us. He's a contract engineer and broadcast engineering consultant. So Nick, I think why don't we move directly onto this this topic that I think is a little bit juicy, and that is Arg, mighty, the subject of FM pirates. Pirates on the air. They be pirates. And some markets, we have 40 channels of pirate radio. This is
my market is 40 channels of pirate radio.
This isn't Scott Shannon's pirate radio from the 80s or 90s. This is the undesirable kind of pirate radio. Here we are, dues-paying members. You know, I own stations. We pay regulatory fees every year. And fortunately, in our part of the world, in Mississippi and American Samoa, we're not faced with pirates. But in areas of really high population concentration, especially where you have a lot of niche audiences to be served, like the Cuban population in the Miami area, or the Venezuelan population there in the Miami area. In your part, in the New York City area, you've got populations from all over the world that don't have maybe in programming in their native language. Or you've got people that just want to, play music on the air and sell some ads and make some money or have some fun. Doesn't matter who they're interfering with. So talk to me a bit about pirates and what you've been doing to help nab them.
Well, here in New York, it's been a very interesting ride with pirates. And probably the most high-profile pirate in New York goes back to 1986 with Alan Wiener when he got the ship that he anchored 3.5 miles offshore, thinking he was in international waters, and started transmitting on I believe it was 1620 AM and 103.1 FM, and he got busted after a few days. The federal marshals came in and seized the ship and took everyone away in handcuffs, and well, that doesn't happen anymore. It's almost the Wild West. You have a station, for instance, in New York on 95.5, and you can find a pirate on 95.7 or 95.3 sitting right in their HD carriers. There's a case in the Bronx where I'm driving up in the Bronx, and there's WFUV, which is on 90.7. And I'm staring at their tower, which is off in the distance about a mile. And I'm hearing this interference, and my radio desenses in my car. And I look up to my right, and there's this probably homebrew or Chinese-made antenna, kind of crooked on a pole, on the roof, and I tune one click over, and they're blasting away about 250% modulation on 90.9 with a 90.7, a 48 kilowatt 90.7 a mile away. So that's what we're dealing with here in New York, or in the case of my translators, where they're actually on frequency. They're co-channel. And we had one group that had a pirate radio station, and the owners of this station decided we're going to contact them first. All right, fine, do what you want to do. And they contact the guy, and he says, well, he writes a letter to the FCC. Says, how come they got a license? Why don't I have a license? I want a license. And it doesn't work that way.
Yeah.
So they wound up shutting him down. But you have to go find these people, and there's 40 of them. I have my one frequency with the one translator on it in Manhattan. There were 5 other stations on that frequency. We managed to clear them off. It took about 1.5 years, but we've managed to, working with the FCC and saying, this is where they are. This is the programming that's running. Hey, look, we found a website for them. They gave a phone number on the air. Here's all this information. Go do something with it.
Wow. Okay. So I guess it's like playing whack-a-mole. And it's a really slow game of whack-a-mole, because you can't enforce these yourself as a broadcaster. But what's the best thing you can do to help the FCC and to motivate the FCC to enforce the laws protecting your frequency?
Best thing you can do too is when you go out, take pictures, get an address. Be very careful when you're doing this, by the way. You're not the A-team. You're not going to go running in there and knock on their door. Don't do any of that. You don't know who's on the other side of the door, and that could be the last thing you ever do. So you be very careful. You do this in broad daylight, and you just have your car. You don't go crazy. But we do get out with a spectrum analyzer and take at least a signal measurement, and you can kind of backwards calculate how much power they're putting out. And some of these guys are putting out 2 to 3 kilowatts ERP. They're running little Class A stations off the roof of their house, which sometimes you can go after you can relate that to the FCC and say, hey, this is not safe for anybody living around here radiation wise. Or you can go after the one case we went and sent a letter to the business owner, to the building owner, and said, listen, this is going on your rooftop. Do you know about this? And they didn't. And they were shut down pretty quickly, not by the FCC, but by the building owner, who said, get out.
Yeah. Yeah. It's interesting how private enterprise can move pretty swiftly, especially if there's ownership. You know, hey, I own the building, and I understand you're doing something here that well, are you paying rent to be on the roof? No, that's probably the quickest way to get somebody out.
You go through certain places in New York, and you'll see there was one that was by the George Washington Bridge. There's you come across the George Washington Bridge in Manhattan, and there's apartments that are built literally over the road on the bridge. So you go in the Cross Bronx Expressway and you go underneath these apartments, and you looked up on these apartments. There was these two Rubbermaid containers hanging off of the balcony, pretty high up on these apartments. They were radomes for the antennas to try and hide the antennas.
Okay.
And this guy was running a 94.9 and 95.3, was running two stations up there with radomes. He's since been busted, but that's what you're dealing with. And you'll see apartments where there's just this coax coming out the window and going up to the roof. And you know what's going on when you look at the roof, because you learn to spot these antennas. That 5/8 whip Dominator antenna, that seems to be the choice of antenna for pirates.
Well, I've heard of this, and maybe I've seen them on eBay. A 5/8 whip, so it's vertical only radiation, right? Yes. Yeah. So, I mean, most FM broadcasters were used to circular radiation. That's what most of our antennas are. And unless you have a channel 6
in your backyard and you're a non-com, then you know all about being vertical only or some kind of weird mixed polarization.
Yes, exactly. I've put one of those up myself. In fact, I was looking for it online. I can't find it right now. But Bob Surrett from Shively, he used to do a lot of talks at SBE meetings and other national things. He has a photograph of a Shively antenna hung out of the second floor window of a residential home. And it's a great picture. I figured it'd be on. I figured I'd find it with a Google search, but I haven't found it yet. It's an awesome picture. So if these people are just using whip antennas, I mean, that's hard to differentiate. I mean, it doesn't stand out like a circular, like a rototiller style antenna or a ring stub antenna does. It could be anything. It could be a two-way radio
with a bunch of two-way or public safety or anything like that. And it's just, oh, look, there's another whip. And to the untrained eye, you have no idea what it is. You do see an FM antenna, go, what's that weird egg beater looking thing up on that roof up there? And a building owner might, if he's not paying that close attention to their rooftop, they might not even notice that it's there. Just, oh, there's another whip up there that someone put. It must be the police. It must be the fire. It must be our two-way company replaced something. Yeah. So it can go on for a long time without being noticed, except it's noticed on the dial. These guys are sitting first adjacent to full Class B signals in New York City.
Okay, so do you do a little direction finding to locate people? Example: what if I lived in a 3-story walk-up and I had access to the attic area or to the middle of the roof and it was kind of hidden? In other words, you couldn't see the antenna from street level walking around. How would you find me if you can't see my antenna? You can't see my antenna. You can't verify that there's physical apparatus there.
Generally driving around with a whip, like a quarter-wave whip on top of the car, and you kind of do a crisscross pattern to figure out, okay, it's coming from this direction. It's getting stronger as we drive here. You hop out of the car, and Mark Humphrey actually makes these. He makes a little loop that goes on top of his spectrum analyzer, and you can turn the loop, and you can figure out, okay, it's coming from that way. It's either coming from behind you or coming forward. That's how it's not a full Yagi or something that's directional like that, but it's very small and doesn't look ridiculous. You're not getting out of the car with a 7-element Yagi holding it above your head. So as you're driving with the quarter-wave whip, you go, okay, it's getting stronger in this direction, so we're on the right spot. And then you just narrow it down, narrow it down, narrow it down. And in the case of something in the attic, I might be able to figure out which house it is. I might be able to figure out which group of houses it is, at least a block that, okay, it's somewhere on this block. You might not be able to pinpoint it exactly. Usually, like there's one guy in Patterson, he's still on the air, and he has a 45-foot tower of Roan 55 next to the house with one of those Dominator antennas on top of it. It's fairly obvious, but again, the average person, oh, it's a ham antenna. It's some wacky radio thing. I don't know what that is, so they're not going to know what it is or or turn it in, they might find that they can't hear a few stations either side of that on their radios anymore and not know why.
Okay, so let's say one of your customers, one of your contract customer stations, either in New York State somewhere or in New Jersey, they're getting interfered upon either with an adjacent channel or a co-channel pirate. You go locate the location, or at least the approximate location, of the transmission equipment. It's got to be in that building or that building, or hey, it's quite obviously right there. You document this, maybe photographs, you take some signal measurements, you show it's all there. You've done all this work. The station is paying their regulatory fees. What do you do with this information now, and what do you do to get the FCC or somebody to do something about this illegal operation that is causing harmful interference to the rightful coverage area of a licensed broadcaster?
Usually what I do is we gather the information and I have the station submit it to the FCC directly, usually to the field office in New York or whatever, or Boston or whatever city it happens to be. I'll have them submit it directly, because coming from them, it's better coming from them, coming from me, because they're the licensee and they're the ones being affected by this. Or if you have to get the FCC attorney in Washington involved with this, which I've had to do on a couple of situations where they actually walk down to the FCC, and one of my stations even wound up having meetings with the enforcement division of the FCC saying, look, we got to do something about this. This is hurting our business. And, you know, that I think in Washington, they don't fully understand the breadth of the problem in cities like New York and Miami and Boston, where it's just, you go up and down the dial. And I play this game with my wife. We go up and down the dial. And I go pirate, legitimate, pirate, pirate, yeah. Legitimate station, pirate. And she's gotten good. She can tell what they are now too. There's just a certain thing about most of them that you can pick up and go, yeah, it's a pirate. He's running like 300% modulation.
Yeah. I've done that in Miami, actually. I've played that game too. Yeah. Wow. And now some pirates have great audio processing. Others have none, but they just crank the modulation way up so they're as loud as everybody else.
Yeah, and it winds up being distorted. And you see those guys, and they're so loud that they're actually interfering with their stereo pilot. And the pilot light is turning on and off with modulation on your stereo. Some of them are probably running, I don't know. I mean, they could be running Omnias, not that Omnia endorses pirate radio by any means, but they could be running that, or some kind of software-based processing like Stereo Tool or Breakaway, and they do sound pretty good. Mm-hmm. You hear it go, huh, you got better audio than this guy over here is a legitimate station. So it's sometimes the dead giveaway is, wow, that's really bad audio. It sounds like a guy's yelling into a tin cup that's hooked to a telephone.
Yeah.
Sometimes there's a couple of guys in New York that have these pirate stations, and they're using professional voiceovers too. So there's produced sweepers and jingle. It sounds real. So to anybody listening, it wouldn't stick out like, oh, that's weird. What's that craziness going on? It sounds like a real radio station.
They're so brazen they call themselves Pirate 101.
I mean, for years, there was Hot 97 in Boston. And they actually, after Hot 97 was sold in Boston, I think it was somebody who worked there who did this, took all of the imaging over, and it was Hot 97 Boston. It was all the hip-hop imaging that they had there. And they were playing it on here, and it sounded like a legitimate radio station. It didn't sound like a pirate. They built a studio. They had web streams of interviews and people coming into this studio that looked nicer than a lot of studios that I work in.
Wow. Well, as we were talking about before, it can take a long time for the FCC, and maybe working with the U.S. Marshals if they need to shut somebody down. Sometimes it's an easier process. Sometimes it's a very difficult process. The perpetrator may be very difficult to deal with. And I still believe that we just need to privatize the enforcement of this and just turn it over to a nice Sicilian family in New Jersey. And the problem will absolutely get taken care of. Yeah.
It would sure be a shame if your antenna were to fall off the roof.
Yeah.
Some guy whose initials are TS. I think Tony Soprano could probably take care of that too.
Exactly. All right. I mean, hey, I'd rather pay my regulatory fee to somebody named Gambino Instead of the FCC.
It'll get done. It'll get done quickly. It might not be pretty.
Right.
It might not be what you morally agree with, but it would get done.
Yeah. I knew this guy. He was a pirate operator. Now he's swimming with the fishes.
See that guy hobbling around over there? He was a pirate operator. Now he has no kneecaps.
There you go. All right. Hey, Nick, maybe you've heard on the show before we do a little tip of the week as the last thing we do. We're going to do that when we come back. So think of a tip of the week real quick. And our show is brought to you this week in Radio Tech by our friends at Lavo. And so let's hear from them. We'll be right back.
There has probably never been a better time in history to buy a new radio mixing console. Today's consoles are more sophisticated than ever, with more features and functions than you can shake a stick at. But have you noticed how complicated they are? There's a sea of knobs and switches and displays and buttons. Some of them look like you might need a pilot's license to do your show. Well, a board doesn't have to be complicated to be powerful. Just look at the new Ruby mixing surface from Lavo. The first thing you notice is how smooth and streamlined it is. Ruby has lots of cool tech, but what it doesn't have is that confusing ocean of buttons that clutter things up. Now, we all know that there are some console features the jock only uses once in a while. So why dedicate controls to them? Ruby fixes this problem by moving those once-in-a-blue-moon controls to a touch-sensitive, customizable GUI that happily shares screen space with your other studio software, helping you fight control room clutter. Thanks to this design innovation, talent that use Ruby produce smoother shows with less errors. Controls that are used the most fall naturally to hand, while functions that rarely need adjustment are easily controlled with just a couple of clicks in the context-sensitive GUI. And Ruby has cool features you won't find on other boards, like Auto Mix, an intelligent gain writing function that guarantees the perfect mix for multi-mic morning shows and call-in segments. Dual mode snapshots that instantly switch the motorized faders between on-air and production modes, and enough DSP and I/O options to make even your pro sound pals green with envy. And because quality is as important to Lavo as it is to you, every console is proudly built to fanatically precise standards at Lavo's own factory in Germany. If you're ready to declutter your control room, do yourself a favor. Check out the new Ruby and the other cool Lavo radio tech at www.lawo.com/TWiRT.
Thanks a lot to Lavo for sponsoring This Week in Radio Tech. Really appreciate them. Hey, you may have noticed a new microphone here. I got this from my buddy, Bob Heil. Here's the box it came in. It's the Heil Sound PR77D from the Deco series. Now, it's supposed to sit upright like that, but I don't have a desk mount for it, and if I did, I may not use it because it'd be in my way. So I just put it on my usual mic arm here, and so I just installed it yesterday. Not much to install. Plugged it in. I went and turned off the phantom power on my mic preamp. I use a DBX 286S for the mic pre, and you can see the mic XLR plugs in the back right here. So I turned off the phantom power, which I use for this mic, the Sennheiser mic, and there you go. I'm liking it. Apparently it has the same capsule in it as my other favorite microphone, the Heil PR40. So if it sounds like a PR40, it's because it's got the same capsule, and it also has really fantastic rejection off the backside. Now, this isn't a full review. I'll do a review probably on YouTube sometime. But watch this, or take a listen. Okay, now I'm talking in the back of the microphone, and I bet it sounds pretty lousy, doesn't it? It's a lot lower, and there's mic processing all through this. So whatever I'm talking is getting brought up. But if we did this without any mic processing, you would say, hey, I can barely hear you. Supposedly it's got about 40 dB of rejection off the backside. So that's kind of amazing. Obviously, the design, it looks like the famous RCA 77 microphone. First mic I ever used in radio at a public radio station. So, Nick, what do you think about that, dude?
I think that's pretty cool. One of the first microphones I ever used, too, was a 77 DX that I think it came from NEWAM at some point along the line.
Oh,
and
wow.
Yeah, and I wound up using that. And there was two of them. There's one in the newsroom and one in the main studio. And you could tension, I remember there was a tension control on the ribbon. and it was a roll-off control on the ribbon. I'm trying to remember exactly what it was without sounding like a complete idiot on this, but it was I don't think it was tension, but it was a roll-off, and it did something where it moved the ribbon back and forth for the pattern. You could change the polar pattern on it, and you could also change the response on it. It was just a really different, warm sounding microphone that did not sound like anything else that you'd use today. And I think that's just so cool that someone put some more modern, more robust capsule in there, and Bob made it look like the 77. You get that same flavor without it being, the ribbon was very delicate.
You know what he could have done, but Bob wouldn't do this. Bob could have, and Bob's been a guest on our show before too, by the way. He does a show called Ham Nation on a different podcast network every week. Bob could have done something. Again, Bob wouldn't do. Somebody else could have, taken a mic of this design, this classic design, and put just frankly, a cheap Chinese condenser, large diaphragm condenser in there. And then you'd have something similar to the cheap microphones that I've reviewed here, the $14 condenser mics that actually sound kind of good, but they don't have this kind of rear rejection that this does, and they really don't have quite the same sound. But Bob didn't. He used a really high quality. This is a dynamic mic. It's not a condenser mic. It's a dynamic mic. It's not a ribbon mic either. It's, again, the same dynamic mic element as in the PR40, which I really like. Okay, so enough about that. So, Nick, I'm sorry to surprise you with asking for a tip of the week, but anything you want to leave our listeners with that they can walk away with thinking, hey, I learned something, I'll do that.
I think if it's a translator or if it's a low power FM and you're concerned about staying on the air, the tip is make the investment. I have a couple of translators that have a main and backup transmitter. They have two paths if they're a fill-in, so that one comes in on Fios or it's an off-air relay as a backup from another translator. Treat it like it's real. Don't treat it like it's this little weird thing that, oh, it's low power, it doesn't matter. It does matter because that's how your audience is connecting to you, by listening to that radio station. So even if it's a low power FM and you can find it in the budget, if it's only a 50-watt transmitter, for another $2,000, you can get a second 50-watt transmitter and put it into an antenna switch that's low power and have some sort of backup and stay on the air. It's important to again, treat it like a big station, even though it's a little station. It's the mechanics are the same. People tune in, people hear you. If they can't hear you, they can't listen to you.
Yeah. Oh, wow. Yeah. Very true. All right. So spend some money on staying on the air. That's what you're there to do. It's all you have to sell.
Right.
Is that.
Right.
Nick, I've enjoyed this.
It's just amazing. They can have 50 computers. They can have this. They can have that in the studio. It's like, well, how many transmitters do you have? Oh, we got one. Well, what happens when that one breaks or it needs service or something happens to it? Oh, I don't know. I never thought of that.
Yeah. Well, we all could take a page from that playbook. Nick, I've enjoyed terrifically having you on the air, learning about FM translators, some best practices, learning about pirate radio, and about Snowcats. We talked about at the beginning of the show. That was fun. Hey, I'd love to have you come back again and give us some more of your thoughts on the things that you do. I've found that as a contract engineer myself from years back, I got to be, I'm not saying an expert, but I got to be a little bit good at a whole lot of things. And some of them were pretty interesting.
Even plumbing. I could probably do some light plumbing too for you.
Right. Well,
things you learn. But I had a blast and a half today. This was great.
I hope you come back and join us again. And by the way, I may be in the city. Maybe you, me, and Chris Tobin could get together around the end of this month. I think on Wednesday the 28th, I'm going to be in the city for some hours that day. So
that'd be great.
I'll be in touch and see if we can work something out. By the way, we're trying to get another engineer from the city to be our guest, and that is Paul Sanchez. Do you know Paul Sanchez?
I've never met Paul. I of course know the name and his legendary tuning of audio processing. So I do definitely know of Paul.
Well, Paul is going to be our guest someday. We're just trying to get a date worked out where we can both sit down and at the same time and sure we can spend an hour together. So we're gonna do that. And by the way, next week, for a listening note for everybody, next week we're going to be having an amazing show with some guys from Canada. Let me find the exact name here. I should have had it right in front of me here. I'm sorry. Next week, it's Brett Gilbert from Tulsa, Oklahoma. He's going to be talking about lighting technology. And as more radio stations build performance spaces and as we build studios that need to be a bit more TV-centric. We need to know something about lighting technology, and Brett is an absolute expert at lighting technology. He's been doing this for years and years. He's got some amazing stuff to tell us. The week after that, the 22nd of March, our guest is Rob Hopkins, and he represents, he designs open source software called Open Broadcaster. And we're going to find out about how that works and how maybe you can run your radio station completely in the cloud. I think that'll be or on computers at your station. Either way, so good stuff coming up. Nick, thanks so much for being with us. I really appreciate your time.
Oh, you're very welcome, Kirk. This was a blast. This was great.
And thanks a lot to our sponsors, the Telos Alliance and the Telos VX, and all the audio over IP products and audio processing from the Omnia division as well. Thanks to them. And thanks to Lavo at lavo.com/TWiRT for being our sponsor here on This Week in Radio Tech. Also, thanks to Suncast, our producer, does an amazing job, and Andrew Zarian, the founder of the GFQ Network. We'll see you next week on This Week in Radio Tech. Bye-bye.